start by sharing desktop 2. And then let us actually go to where we're going. I don't know why this exists. That's stupid. Okay. So this is still a mess, right? That is not accurate. But what we're going to be doing here, as we mentioned sort of earlier in this semester, is we're doing two things simultaneously. We're talking both about how to write scientifically so that we can create a final document. And then we'll also be taking data and analyzing it and talking about the analysis. So we used to go week on, week off. So 1 week we talked about data analysis and 1 week we talked about literature. And now we're going to combine both of the topics together. So today we'll start off the beginning of the day talking about what the methods for literature review are, because you will begin the process of writing your introduction. So you have some documents that you have been turning in, which are the summaries of whatever papers that you're going to basis your interest on, right? Has anyone not turned in just one of those? Okay, so we need to turn those in, right? We need to identify papers. You should have a minimum of 4 and probably much more by the end of the semester. And each one of them will have a summary, right? And then we go through the process of thinking about how we describe the introduction as a whole. What does it mean to do a literature review? What does it mean to put into words the introduction? What are the important questions that they are asking, right? And for each one of you, it'll be something slightly different. Does that make sense? Okay. So you're also turning in today your personal statements and or your research statements and or whatever things that you had peer reviewed. Okay. Let's start with that. Got it. And then if I have anything else, I will give it to you. Yeah. Thank you.
And it looks like you sent the other one.
Yeah, that's fine.
Did you not imagine? Oh, that's his.
You're turning in Paul's.
No, it was Andreas.
Okay. So similar feedback that I've sort of given out a couple times is just about the importance of thinking about topic sentences, right? Stuff like that, how we construct this type of work. But when it comes to actually writing, we want to think about what the structure of the work looks like. So I'm just going to put a couple different sections for your literature review, which will not include any new results. What sections are we expecting to see? Introduction. Good. Yeah, that's the first one. We got to know where to start. What? So let's think about it. What does an introduction do?
It goes into the background and relevant ideas that you should be prepared for the rest of the scope.
Right. So similarly to how we thought of the abstract, where you start very broad, you narrow down to the idea of interest, and then you focus on the technical section, the methods that you used, then you describe the results and how they impact the world at large. right? The same thing's gonna occur in a literature review, except you have nothing to present, you have no methods. So the methods you're presenting are what you found out. I found out some shit, right? So we're gonna narrow in a little bit, but not all the way down into novel research. Okay, so introduction starts broad. Why should anyone care about this field? Right? Okay, then where do you go? Yeah, you go into the specifics. So you discuss their results, right? So you're gonna skip over, typically you would have methods right here. And we're gonna skip that. If you want, you can talk a little bit about their methods in the discussion, but you're gonna go right to the discussion. Okay. Am I missing anything before the introduction? Abstract, and before that? Title. Okay, and then after the discussion, yeah, conclusion or summary, right? Anything after that?
References.
References. Okay, so this is one thing we're going to start talking about today. All right. How do I write references in a scientific paper?
Like what style to follow, or
Just how do I mention another person's work?
typically if you're citing them, you're gonna say them a lot. So like having them like listed in like number form, if there's like multiple, I guess, people you're citing. So then if you like make a statement or a comment about something, you can cite whatever that person is.
So let's be very careful here, right? So we don't cite individuals. It's not Bob said.
Right.
What is it? What?
Article.
Yeah, how do I write the article in when I'm writing in text?
You can say like other literature has
Specific. How do I specifically write?
You
Read.
feel like they're the main author and then like that. Well,
Et al.
Yeah.
And the year.
That's right.
Okay, so it's first author. So first author. Last name. What is et al? And others. In what language? When do I use et al?
When there's like
How many others is others? So if Isabel and I write a paper together, is it et al? No. There's only two options there, right? So which one is it?
like more than two.
More than two. Is that right?
What if we
More than three? Oh, now we have to fight. Well, which one is it? More than 12?
I think it'd be silly to write three last names or two last names. Excuse me, three last names when you're like citing something. Like it feels like at that point, first name and then it all.
Let's say we write a 3-person paper.
Yeah.
Okay. Let's say it's here's the authors. Laughlin, Grismani, and Adams.
But there's real people.
Yes, this is my first paper. Okay, 3 authors. How do I cite it?
I feel like Laughlin et al. I think, sorry, Chris. If you were listed first as like the first author, then it would be Grismani et al.
So it's going to depend generally on which style of citations, right? So the type that we're using here I believe is MLA. But don't quote me on this. I'm gonna double check when I get home. You mentioned one earlier, which would just be, use a number. And then at the very end, you can reference that number. Sometimes you'll see like a letter like that. These are gross. Yeah. These are
ALA
gross.
format.
What?
The ALA format, which is.
Yeah, these are all language associations, and then the A is American Language Association, and the M is something,
It's
and
something,
one of them is Chicago, and one of them is APA, which is the American Psychiatric Association. They're all styles of citation. So Nature has its own style of citation, and that's this. What? Not Mother Nature. No, the research journal. Okay, so they use a style like this. And I would strongly recommend, who's writing their papers in Word? Word. The software. Who's writing their papers in Google Docs? Okay, both of those are word processors, right? So you click clack on your typewriter, and then it shows like squiggle line underneath, right? Which says, oh, you click clacked incorrectly, right? So that's got some built-in stuff, right? Let me introduce you to some built-in stuff. Zotera. What is that?
a planet.
Sounds like a vitamin, right?
Exactly.
God.
What's that? A god? No, I wish. I'm not gonna introduce you to God on Halloween. Okay, this is a reference. I'm spelling that wrong. Manager. Okay. I spell reference. I don't know how to spell reference. Is it all E's all the way through?
Yes.
Wow, amazing. The more you know. Okay. So what this is a free reference manager, and we can talk about how to use it once you've installed it today. But essentially what you'll do is you will go back to your original place that you found your articles. Before you click the download article, there's a little button. You click the Zotera button, and it will download the article's meta information. That includes all of the authors, that includes the title, that includes the year. And then when you open up your word processor, which is Word or Google or whatever, you click the install extension. So now it'll link to this app that's on your computer. And then you can insert a citation. And you say, okay, I want Bob's reference from 2013. That will show up. And you can change the citation style with the click of a button. So whether we use MLA, which is what we'll try to use in this class, or if you want to write something in the Nature style, or you want to write it in whatever weirdo style this is, you could do that too. Okay. So I think generally speaking, again, don't quote me on this, it's more than 4 authors for et al. But if you don't have a lot of space, no one's gonna get upset. Definitely for this, if this ever happens. You would not use et al here. And if you have a single author,
At all.
no. You would not use et al as well. What if you have 2 authors in the same year? Let's say someone wrote 2 papers in 1 year. I know, amazing, right? What's that? Yes, exactly right. So where do we do this? So we said author's first name. So first author's last name. We said et al. And what are we missing here in this citation style? Year. Good. How much of the year?
All of it or letters?
May 19th, 1990?
Ooh, like
The year,
just the
but how much of the year? 4 letters,
four numbers.
4 numbers. Okay. So let's do 1990. Good. Okay. So the way that we distinguish multiple papers is that if we do this and we have more than one paper, with a single first author, and let me say this differently, with the same single first author. So for example, if it's Grismani et al, Grismani et al, Grismani et al, since you don't know who the rest of those et als are, you would go, 2018A in parentheses. And then the second one would be 2018B. And if you're really crazy, then C and D and so on. So, make sense? Okay. This is what I want to see from now on in your summaries. This is what I'll expect to see in your introduction. Okay. So now let's say that I don't want to be writing this a million times. I referenced to this thing. How do I talk about it? How do I talk about the results? How do I talk about that paper? Which article? Yeah, I mean, so it's really important that if we're using prepositions, I've sort of given maybe some of you this feedback separately, but I want to make sure we're all listening to it at the same time. Using prepositions like the hill, or let's talk about, Jack and Jill fell down the hill, right? Catch a pail of water, you know this, right? So if I start a paragraph and I say that hill hurt their knees, is that okay? Why not? Yeah, a different way of saying that is which hill. So I'm referencing information from a previous paragraph. Similarly, if there is a preposition such as this result, we have to be able to point directly back to which result it is, right? So we can say something along the lines of, the atmosphere has been shown to be made up of candy, citation Grismani et al. This is quite surprising because XYZ, right? We expect it to be made of air, right? That's fine as long as it's right there. But if there's a new paragraph, or if you're talking about, some summary that you're creating, you're saying, well, I've only ever talked about that one citation, you're setting yourself up for failure because you're not practicing the way that we should be talking about the paper. That does not mean we cite it 15 times in a row, but that means in practice with every new paragraph, you have to orient your reader as to where you're pointing, okay? So, Grismani et al. Also showed that when you fall down a well, you need to send a dog to get you help or something, right? That's the beginning of the article. Make sure the dog is not deaf, right? That's referencing the results in the article itself. That process makes sense? Okay. So when we're thinking about methods for literature review, right, we're going to be going through the process of trying to understand what the important questions are. So you have some papers that you've been reading, and they all have introductions, and you're summarizing the papers as a whole, but you should begin to start looking at your individual summaries and see if you are not able to pull together the topic sentences for each one of those to begin your own introduction. So let's say that again. Okay. Here's your individual papers. Okay. Okay. You are extracting from it a summary. Okay. And it's great summary because you wrote it really good. So there's a topic sentence. And then some supporting stuff. Right? And then the next one, a really strong topic sentence. Right? And then some supporting stuff. And then the next one, Topic sentence. Short those. Okay. Good, great summary. Really describes the article well. Okay, so now let's do that again. Second paper. Leads to second summary. Right? Third paper. Leads to third summary. Okay. Now, if I'm looking at all of your summaries, right? I should be able to take all the topic sentences. Pull them out. Grab them all. Is that a coherent story? Why not?
They're all like disconnected.
Imagine you did it right? Imagine it's not your first draft. Each one of these should be an independent idea. That's the most important part of the paragraph. And all the other sentences behind it are supporting that topic sentences. So if the summaries are well written, we've gone back to them, we've addressed them, we've made them longer if necessary, we've improved on them. Then the important statement there is the first one. So if I pull out the first one, the first topic sentence, like every single line of my summary, right? Then I'll have the 3 or 4 most important things about that summary. Right? Depending on how many paragraphs it was. Same thing is true of the next one, same thing is true of the next one. Okay. So now I have a whole bunch of really important things that I thought were important. The only thing that's wrong with this is the organization. Because usually when we write a summary, we start why it matters, what they did, what are the implications. So now you need to grab all the first lines and put them all near each other, and put all the second topic sentences all near each other, and all the third topic sentences all near each other. But do you see what you've done already? No.
Like organized it.
Yeah, so now you've organized it again. So remember we have introduction, discussion, and summary. Detail, a summary of a summary. What is this? Summaryception? Okay. Yes, that's exactly what it is. Distilling knowledge. We take knowledge from everywhere, we gather it up inside of our brain hole, and we try to put it back out into the world. Right? If I take what this person learned, take what this person learned, I take what this person learned. This is the process of cohesion, adding it all together for a cohesive story. So this is where you're going. Right? So you have all these summaries. You have all of this one. So this is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Okay. Maybe your second summary was longer. Okay. So your first sentence here should all be of the same structure. Why was I reading it? This paper had to do with blah, 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 right? Got to the first paragraph. So all your first ones, they go here. 1, 1, 1. That's your starting point. And then 2, 2, 3, 2. And then 3, 4, 4. Okay. Now you have all these really good words. Now you massage, add details, add important parts. Right? You can go back to your summaries. You can feel like you want to generate and connect these sentences in a better way. Right? But this is how you're going through the structure of writing. Does that make sense? So you're like, oh, I thought the summaries were just for fun. I didn't take them seriously. You gonna have to do them? Oh. That's what we're gonna do. Is that process okay? Yeah.
We're doing that with which summaries? All of them?
Not the ones that you did for my Mars stuff. No one cares, right? That was the process of learning. Well, I mean, I care, but I'm not going to force you to care about Mars. But what I am going to force you to do is, I told you at the beginning of the semester that we would do a literature review. And you are going to learn about a topic of your interest whether that's physics or astronomy, I don't care. But you're going to learn something that you want to learn. Okay? You're not going to do novel research on that thing, right? Because I don't have the funds to get a super collider here for you to do string theory. But let's say you're interested in string theory. Okay, paper. This is like the state of the art of string theory. I can summarize it. I can tell you why it's important. I can tell you what people are doing, and I can tell you where it's going. That is a literature review. You should be able to do this as a skill, because let's say you decide not to be in physics anymore. You get a job at Google. Okay? Google's offering you $400,000 a year. And they want to know whether or not you are capable of running beta testing for a brand new software package. You say, well, maybe not, but I know how to learn about it. So you go and you find everything that's been written about that package. You see what the state of the art is. You see where people are asking questions about this large language model. And then you say, it seems like most people are sort of coalescing around this problem that I think we could solve if you just give me 20 people. Right? That process makes sense? So regardless of whether you're doing this for yourself in terms of industry, whether you're doing this for your professor, for some research that you're doing, this type of writing is the most invaluable part of writing because it's summarizing the field, right? So that's why we do literature review at all. Yeah.
So, for like the papers we send you, can they be a little like different from each other?
Sure. I mean, one of them can't be like fluid dynamics and the other one is like, you know, how gunpowder works. There needs to be a thread, right? So you may find as you're going through, you're like, oh, I actually fucking hate this topic. That's fine. I don't mind, right? But just like we talked about with references over here, you're currently building your references, right? So the work that you're doing right now in reading these summaries and writing these summaries about these papers is the stuff that you're going to use in order to be able to do the literature. So if you spend a little bit of time doing something you don't care about, that's okay. But you'll need to, you know, read a few more papers to make sure that you kind of have a broad sense of what you're looking at, right? I don't need you to read the method sections of each of those papers. In fact, I won't expect you to. But I will expect you to be doing the parts that we care about, right? What was the introduction? Why did anyone care about this problem? What did they find? Was it relevant to anyone ever? Right? And remember how we're selecting papers. We're not just grabbing whatever comes up first on Google, right? What are we grabbing? How do we determine credibility? What are some of the rubrics for determining credibility? Yeah, number of citations in a certain amount of time, right? So if it's been out for 35 years and 2 people have cited it, don't read it, right? Probably. I mean, unless it's a really niche field, like how cats drink milk, which there are papers on, by the way. The physics of cat and dog drinking milk is actually fucking hysterical. There's papers on it. That process makes sense?
Wait, it's how much water?
Yeah, but it's just cooler with milk because you can see the liquid. Yeah, they have like high-speed cameras that do it. And fluid dynamics. And like capillary action or something, or scooping, whatever. Dogs and cats do it differently. That's the only thing I read from those papers. Okay.
And you summarized it.
Not in this class, no. Okay, does this process make sense? Okay, so what are we doing next? Today, next day, next day, next day. First things first. I think it's Zotero. Zotero. Let me just double check. What is it? Zotero.
Zotero.
Almost got it. Okay, this is the first thing. Okay, and then we're going to go back to our papers, wherever we found them. Now you have the title of the paper. So you go back into Google, right? And you just go back to that original page, not the one where you downloaded off of Google Scholar. So let me show you a difference really quickly. All right, so let's do. All right, did that work? All right, so let's pull this one, go to Google Scholar. Someone give me their paper that they want. Oh shit.
There you go.
Semiconductors. Someone in particular? All right, let's do semiconductors review. All right, so here they are. Okay. See this little button? You see that in my Google?
Nice.
You don't have to use Google. You can use Firefox. You can use Safari, whatever you want. But see that save to Zetera? It's an extension. So what I'll do is I'll come down here and I'll make sure that it's open. It always screams at me if it's not open. Okay. It looks like this. Here's my password manager or reference manager. You'll see, I do not expect yours to look like this at first. So, you know, it's easy. Every time that, no, what I mean by that is it really is easy because I used to have to like literally put them into a document by hand. And this is fucking simple because you just click save. So even if you don't ever end up reading it or, right, so like the use of logistic regression for stellar classification by Barocci, I've cited it. I haven't read it in detail, right? But it's in here in case I need it. All of the work is in here in case I need it, right?
What's the significance of it?
This is whether or not I have a PDF of it. Right, so I can just click that to read the PDF.
All of this down.
Yeah, I have about 900 gigabytes on my computer. I know I have to delete some stuff. But that's for a different day and a different Chrismani. Okay. So you can go through here. Oh, look, self-citations, we love those. And you know, maybe you want to find your friend. Oh, Guzewich had an ionized layer in the atmosphere of Mars. Okay, whatever. So now that this is open, I'm just gonna minimize it for y'all. It can sit in the background. I don't really give a shit, right? So then what I'll do here is I'll say, okay, let's say this is the paper that you wanted, for example. Okay. Here's where I would go to get it. Or no, let's do this one. This will be better. So here's where I would go to grab the PDF itself. And I'm opening this in a new page to demonstrate how this works. So notice that it just goes directly to my downloads. Right? That is not going to be as good if I go to here. Watch how this icon changes. See how it went from folder to this weird symbol? Like a paper? Yeah, a papyrus. Okay, so if I go backwards, let's see it again. Okay, folder. And let's go to this next one. Oh, damn it, not that one. Let's go to this one. That one just downloaded. Yeah.
These are personal email or these school email?
For what?
This is Florida, registered.
That's up to you. That's your call. I mean, do you want it forever? Yeah. You use your personal. Okay. So notice this one here. It says, I have access to this. Save to Zetera has access to this site. Okay, let's see if we can get a more complicated one and I can show you how this works. So two people. Let's do a big one. Let's do yeah, CERN LHC. Okay, good. All right. Protection of this Large Hadron Collider. Okay, here it is. Wonderful article. Multiple authors is what I wanted to show, right? There is the full author list. Published in 2006. And I can see, oh, this has access to it. So I save that to Zetera. Okay, it says saving. And sometimes it'll just grab the file right there. So now let's go over here. Let's grab the library. And what's the name of that one? Right there. Schmidt et al. Schmidt. Okay. So now let's use it. Right? Because what's the point of any of this if I don't show you how to use it? So let's open up Microsoft Word.
Like
It's
this.
no, it's opening on mine.
Oh, okay. I thought you were looking at it. Like,
I thought it was already open, but it's not open. If you're using Google Docs, don't worry, I'm not gonna leave you out. Let's show how this works on Drive. Docs. Okay, here we go. Here's the CSUSB. Actually, let's not do that one. Let's do oh gosh. Which one do I want to use? Final exam solutions? No. Don't worry about it. Okay. Nope, this is not the right one. I need something I've written. Here, let's write a blank one. Okay, here we go. See how it says extensions? And see how it says this word next to it, which is the word that we just learned? And now I can add and edit a citation. What's that? Okay. And here's another example. So I'm going to open up a blank document in Word. Sorry for my inability to speak today. Okay. And let's do some writing. It's a writing class. So this is a writing class that I kind of enjoy. Okay. And let's cite Isabel. And so we go to, where do we go here?
oh no.
Where? Oh, Zotero. Good, it's right there. Okay. So now what I can do here is I can just edit a citation. Come on now. Don't make me look bad. There it is. All right, it's on this side here. So the first thing it's going to ask is for my document preferences. And I'm going to say, of course, I want Modern Language Association 9th edition. That's what I claimed I wanted, right? Okay, good. All right, so this is the type of class. And then here is if you're using like the Zotero plugin with Word, this thing will pop up. And now I can access whatever I want. And interestingly enough, I don't have to be that specific. So like if I kind of remember the name of the paper, I can be like kind of vague. So let's say I want to be like polar. Oh, awesome. Here's all like Barth and Dick, ozone and the polar hood of Mars. Done. Cited. Right? Now, let's say that's not the style of citation that I want. Maybe I'll change that one so you don't laugh so much. Let's edit that citation. All right, let's get rid of it. And let's do mesosphere. All right, here we go. So Annie Martinen's recent paper on the mesosphere. Good. Yeah.
I think from here.
Yeah, so that's a very good question. So clearly when I was trying to cite the MLA, I was wrong, right?
Mhm.
So let's go into document preferences. Let's figure out what I did wrong. Is it IEEE? Let's find out. Nope, that one's horrible. That's the worst one, right? Okay, let's try it again.
Is it APA?
It might be APA. Or it might be Chicago. Hold on, let's try Chicago. Let's fucking go, boys. Okay. Chicago. So this is the Chicago Manual of Style, apparently. And the two things that you're going to notice here is that Zotero actually prefers to put the entire citation inside of a parenthesis. But if you are going to refer to it, so Crismani et al. Shows, blah, 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 Then you do Krismani et al. And the parenthesis only goes around the year. If, however, you're making a generalized statement, like the sky is made of candy on Halloween, and normally you would say period, there the whole citation is going to go like this. This is a writing class that I kind of enjoy, Matanen, right? The process makes sense? Okay. Oh, what else do I have to do? Well, the nice thing about this, so let's say I want to have multiple citations here. And I'm like, oh, someone else did say that this was a good class, sort of. And that other person was, come on now. It's another word I want to use. Make some stuff up. Let's just only cite myself, obviously. That's mine. Okay, so hey, yeah, that's something I did. Good. So look, now it knows how to organize them, and the order in which I put them into Zotero is the order in which they'll come up. Generally speaking, this doesn't really matter unless you find like one person mostly talked about it and everyone else kind of talked about it. Usually you give them seniority, but I won't hunt you down for this. Okay. Okay, so now I have two citations. You see that they're separated by a semicolon. That's totally up to the style, right? So if I go in here again, and let's say you're writing for something else, and you want to write for the APA for some reason. Okay, now it's different. Now it's alphabetical, right? Or let's go back to our least favorite version of all time. Oh, science is actually fun. That one's fun. Okay, so science is 1, 2, and disgustingly, watch this. Okay, if I add here at the very end, okay, I'm going to add a bibliography. What's a bibliography? Exactly. So this builds the bottom for you for free at some point.
That's something.
See if I did it right. There it is. Good. All right, so all I have to do here is write the word. Yes. Okay, see? And then I would just bold that. And I'd be like, that's my section, right? And because I'm using a reference manager, this is all going to come for free. So unfortunately, the way that science works, and we will not be doing this ourselves because it's very confusing, they will simply reference in whatever order it first happened. So this is the first reference, so it gets 1, 2, 3, 4, 5. So even if you talk about stuff non-sequentially, it happens that way. I personally prefer the Chicago style, and I think you'll see that in the context of most scientific papers, that it's much easier to say, well, you know, Margaret wrote about this in 2003. And so you can remember both of those things rather easily, as opposed to trying to remember 1, 2 from a science paper from, right? That makes sense. Okay, so let's go back and we're going to switch this back to
What is the J stand?
where?
It says MMJ. Respond.
Oh, you never even learned my own. Okay, let's say I'm going to write Journal of Geophysical Research there. And now you see that the references are alphabetized. Does it for free.
You have 2 middle names?
MJ.
Oh, that's a good question. I guess you'll never know.
From Spider. There you go.
That's correct. I was born before Spider-Man, and so no, I'm just kidding. Does this process make sense? Any questions? Yeah.
So writing and planning being more of like articles to review and then combining them into one, but we're making a summary first for each one and then combining them.
So the process every week should be finding a paper, reading it, summarizing it, giving me the summary. Every week from now until the end. Yeah.
How many should we have?
I would like you to have at least 2
Okay.
by now. And by the end of the semester, if I count my weeks properly, I believe that is a total of 8. So 6 from today onwards. Now, you can save yourself a lot of trouble. Okay. Because how do we go about doing a literature review? How do I know where to go? Let's say I started and I listened really well to myself like 4 weeks ago, and I got a review article. The review article cites papers. Oh, so that's a great place to start, to look at these other papers. So let's say they say, you know, in 2003, someone showed this novel result. Why don't I choose that as the next paper to go look at what was so novel about their result? Because remember, in a review, you're getting sort of the broad strokes, right? But that person, whoever they're citing, is going to contextualize their own work. They're going to tell you why it was important. They're going to tell you why they were motivated to do it, right? So as we go through, we don't need to grab 7 different reviews. That's insane. We need like 1 or 2 reviews that give us a broad understanding of the field, and then some pathways down to begin to understand what the important questions are and what people are trying to solve. Does that process make sense? Okay. So I will accept anywhere between, you know, 4 review papers and 8 articles, something in between there. The process makes sense? And you know how I'll know that it wasn't enough for you?
If we get it all done?
No.
Okay. If it wasn't enough.
Yeah. Exactly. So the whole point of this is we are not reading for the purposes of making me happy. I don't give a shit, right? I'm unhappy every day. So instead, what we want to do is we want to be able to write about a field that we're interested in. And if you can only write half a page, you haven't read enough, right? Back to the drawing board. And you're going to keep going through that process. And no, we're not putting it into Chat GPT. Be like, can you turn this 1-page summary into 6 pages by using too many words? No, you can't do that. Kobe, don't even with me. Yeah. It needs to have this. Okay. This is the only one here that it won't have. It will have no figures. Unless you really, really want them, but they won't contribute to page length, right? They'll be added at the end. And the way that I'll know that it was good is that it's good writing, right? So you might say to yourself, well, you know, I just explained it in 1 sentence. I'm like, did you though? Right? Every other paper that you read took like 3 or 4 paragraphs to just have the introduction, right? Why was your introduction 1 paragraph? Does it really only have 1 important concept? No, probably not. You want to think about all of the things that people are saying. How do we conceptualize them properly? Now, do I expect it to be as well written as one of the review papers? Of course not, right? But this is the process of, in 3-4 weeks, you'll hand me the first draft. Maybe it's not finished. That's okay. We're going to get better at writing together, right? That's the whole process. You give me the thing. I say, hey, this is good. This section's great. Keep working on this section. And then I hand it back to you, right? Further questions? Okay. So now, folks, we're going to talk about some data analysis part of the computational. So I told you that we were going to mix together sort of some of the writing parts versus some of the data analysis parts. So you 2 have an update for me? Yeah, don't you have a written update for your project? That's moving forward, right? It's not like you didn't do anything this week. Okay, so you're going to spend a few minutes working together and writing it up. And then you folks are all observational, right? Okay. So we're going to talk back about the astrometry project, right? So everyone now has had the opportunity to get data and to get data off their computer, right? Sorry, off the telescope and onto their computer. How's that going?
Reading through the code.
So you haven't done anything with it. You can just say that. I need feedback, right? To know where you guys are. Okay. So let's look here then at let me get rid of that. Yeah, I'm not gonna save that. Okay, let's get rid of this. All right, so let's pull up the
I think the quickest thing that I was able to do, be able to like call a file that we wanted to look at. That was kind of nice, but I'm still trying to reason through like what each cell is doing to the data and like how it's processing and what's so significant about it.
okay. So you may have missed when we first showed it because I think you guys were at Disneyland.
Yeah, but I was kind of caught up on speed as well.
Okay, so this download stuff.
That, yeah, so this is talking about importing things, and then that is talking about like what file you open,
Mhm.
and then the file destination is fine, calling it is fine, and then printing it out is okay.
Yeah, what's this stuff?
I wasn't clear about like how it was. I know that it's like separating certain pixels into groups. I get that part, but I'm not clear as to like I guess the significance of like the color scheme. Like, why are we looking at it?
Yeah, so this is actually the red, green, and blue channels.
Yeah.
So that's what the third dimension is. Red, green, blue, and this is the difference between red and blue.
Okay.
So if we look back at the original image, we'll see that this is very blue in here, and this is kind of red. So therefore, the difference between the blue and the red channels would support that, right? You have blue in this region, and you have red outside of it. And you have blue in this region, and you have red outside of it.
Okay.
Good. Right?
Okay.
So these are ways of representing the data. Okay.
Would that be considered process? Like,
What do you mean processed?
now that you've ran it through this program, would that be a processed image that you now kind of like now it's being separated by light colors, like the color of each like
It depends on what we're doing, right? So the point of this exercise is just to show you how to download and then manipulate the data. So in order to do that, we have to talk about all the things we can do with the data, right? Okay, so I'm going to wait for them to finish and then we'll talk about this more. Jose, do you have a group that you're working with?
yeah.
Oh, okay.
Yeah.
Yeah. Yeah, of course. Yeah, I'll send her an email. Find out what's going on. Yeah. Yeah, I don't mind. You know, I think that having that option, considering that we still have many days, is good. So I'll get in contact with her. Okay. That's fine. So folks, we're going to talk about how to do astrometry. You guys ready? Yeah, we weren't ready to just break into groups. That's okay. He just started asking questions. Yeah, and I was answering questions. Okay. All right. No, that's not a bad thing. I'm not mad at any of you. Okay? You guys started working. I'm not mad that you started working. I just want you to, I don't want you to miss anything that we're talking about. So hopefully everyone got to here, right? And that's the point, getting the data in. And you may have found that a lot of it is uncommented and actually very annoying to use. Good job, Mateo. This is a lesson in what not to do, right? Okay. So as we just mentioned, you can move images around. You can stack them differently. You can rescale them. You can resize them. These are arrays, right? And what we're going to want to do here is we're going to want to think about how we can analyze objects in the image. Okay. So what I mean by that is if I go and I look at this image here, you will notice that I did something called box start, box end, box mid. Okay. And in this process, I I found what I thought was a star, something bright in the picture, and I zoomed in on it. So rather than a 1024 by 1024 image, I zoomed into a box of only the size 100. All right. And I separated it into red, green, and blue. And then I have the red minus the blue here in the bottom right-hand corner. You'll notice a few different features. You'll notice here there is light, where in these images it is not so obvious. And that's because both of these have the same relative brightness. So when you get rid of them, you take the difference of them, then the main peak disappears and you end up being able to see the background. So when I say the background, it's because I'm cutting through, let's say the midpoint of this image right here, right? I'm just grabbing one individual slice right through there, okay? And I plot it like this. So now it's 100 by 100, but I'm plotting it two different ways. Let's see if I can show this on the board, okay? Slice this way, chomp, slice this way, chomp, okay? I don't know which one is which, but it won't matter for the purposes of this argument. So you see the background. It's not at 0. This means there's light in the image, right? Being recorded. Now we will talk about this in practice. Maybe it's not quite real light, right? There's a reason we take dark frames. We'll talk about that probably next week. But this background here being non-zero is something we want to see if we can tamp down on. So this is adding some contribution that you will have to subtract off of here because we want that average to be 0, right? That process makes sense? Okay. The process of astrometry, which is determining where something is on the sky, is not trivial. Okay, so what do I mean by that? So here's a little star, twinkle, twinkle, little star. Okay, I found out where it was. And here is defining the Gaussian function, which will hopefully describe which pixel this is centered on. Now, this will not work perfectly because the choice that I made here was on a slightly saturated pixel. But generally speaking, I can fit a line shape to this object to find out where the central piece is in X and Y. Okay? Now, when I say X and Y, these are sky coordinates. So if I want to find the distance between two things in the sky, I find out where they are in my image here and here. And if I have something that's not moving and I have something that is moving, then I'll be able to see that motion over many, many images, right? And by taking the exact pixel location rather than just guessing for the center, I get a more standard understanding of that process, right? So here's fitting it. Here's the original data, right? I defined something called Gauss X AB. X is going to be all of my dependent variables. A and B will be parameters of my fit. Okay. And then I know that it's 100 bins long. And so I can just make the Y data. Every single one of the X's, I'll just place it in here. And then I can fit it. And it's really difficult. It's called curve fit. Okay, you just download it, curve fit, you give it what curve you want. So I told it I want Gauss. Remember that function that I just defined? It's right here. And then here's X data and here's Y data. And the Y data is the image itself. That's what I'm constraining it to. And the X data is just 1 through 100, right? Whatever I gave it originally. And now I'm going to say, you do all of my work, please. Okay. Oh, shit. It did a really bad job, right? So what happened here? Okay, so something didn't happen very well. So let's define the function a little bit better. Okay, it's AXB plus C. So I need a little offset, right? Remember we were talking about the fact that it has this little offset. So does that work better? Aha. Bada bing, bada boom. Now the green line goes through the orange points, right? And as I add more parameters here, we're going to introduce more uncertainty in those parameters. Remember, you can sort of like imagine an infinitely wiggling line will go through every single point, but it's less reliable than if you just reduce the total number of parameters. But what I can do here now is I can get this answer back out and I can determine where this peaked. Exactly. Right? So I can get exactly the X location, I can get exactly the Y location, and I have a very definite location on this object. And so if it were to move, let's say you're watching anything that moves, whether that's an asteroid, whether you want to watch Neptune go across the sky, whether you want to see stars that are orbiting each other, you now have the technical precision with your telescopes, which remember, I was just talking to Reed about this. I think you can go down to like 20th magnitude, which if you don't realize is fucking crazy. These are 5.5-inch scopes, and you can get down to 20th magnitudes. That is 10 to the power 20, 2 to the power 20 times less bright than Vega. Does that make sense? Let's do that math. So, yeah, magnitude system. Let me just show you the math because that'll be easier than it's just trying to rattle it off my mouth. Magnitude system. What did I say? Oh, fuck. This is why they don't let me do anything. Okay, so 1 magnitude is defined as the ratio of 2.5 brightness. Okay, so a star of magnitude 5 is 2.5 times brighter as one of magnitude 6. So if I write this out, 20 magnitudes is 20 times that I did that multiplication, which is the same as that number to the power 20, right? So let's find out how much brighter Vega is. Let's do Wolfram, right? Because we never ever do math on our own. What? You do Desmos? Is that what all the folks use? No. Okay. All right. Maybe I'm just old. Okay. So 2.5 to the power 20. That's a big number. That's more than 1.
It's more than one.
Right? By like a lot. How big is that number?
It's like 9.0.
Thanks. Well, which one is it? Is it 98,000, 98 trillion, 91 mils. So if I look up and I see Vega, if I can see a 20th magnitude star, I can see something whose brightness, the amount of photons I'm getting, are 10 to the basically 8 smaller. Right? So that's pretty sensitive. Okay, so let's say we want to watch stuff move around on the sky. We could do that. Right? That's the purpose of astrometry. Astrometry is watching things move on the sky, and this includes stars, especially nearby stars. Why will nearby stars move throughout the course of the semester? Yeah, so you actually didn't take this class, so I'm not gonna say that you.
Yeah.
Everyone else should know this. Yeah, Jose took it. You better know this one.
Oh no.
What am I doing right now?
You're walking.
Of course I'm walking, but
You're zigzagging. It's retrograde.
parallax. Okay. It is the orbit around the sun, but what is the important thing about the orbit around the sun? It's how you are all moving with respect to each other. So Jose in the back is not moving very much at all because he's very far away from me, whereas you in the front are moving dramatically. So stars that are closer to us are going to move dramatically, and we can measure their parallax. I'm not saying you should do this, but I'm saying you could see this with the telescopes, right? If you find nearby stars, you start taking an observation now, you check it again in December, it's 2 months, right? Can you see parallax? That's a question. I'm not going to guarantee you will, but it's a question. Okay, so that was a 1D fit, and 1D fits are great, but they're boring as. So let's do a smarter one. So here's my star. Does that look like a star? Does it? Yeah. Raise your hand for this is a star. Okay, both and. It doesn't look like a star, but it is a star. So what did I do wrong here?
With this,
Yeah. Yeah, when I took the original observation, I fucked something up.
maybe it's exposure. It's like,
It's not, which means it's not. No, focused will make it more like a ring, and we can show that next time. This was a weird one that we did last time, remember? Yeah, the thing with the cross. No, collimation. So if you see it, so okay, here's the different things that can go wrong. Okay. Star should look, oh fuck, that's not right. All right, I have to do this right. That's mostly a circle, but it's not a very good circle. Okay.
it's a time.
It's a little bit like elliptical. Okay, so let's do a. That's a circle.
Stop.
Oh, I thought you were supposed to.
All right.
You could do it. Oh shit.
Nice.
Like if you do enough circles, it looks more like a circle.
There you go. That looks more circular, right?
Yeah.
Okay. So if it looks like that, good job. You're mostly done. Okay. What does this one look like? It looks a little bit like this.
Not good circle.
Okay.
Good one.
That means needs collimation. Okay. What if it looks like this? So not just us in this class, right? Hey, yo. Unfocused. You get why that is? Let's talk about the physics for a second.
And like a weird ring.
Okay, there is a curved mirror at the back. The light comes in from infinity, and it's collected here on a CCD. Okay. This mirror can be moved. There's one screw here. There's one screw here. So it can move into the plane that way, and it can move left, right, that way. That gives it 300 degrees of orientation. So that you can take light and it bounces, oops, to there. Right? Collimates, takes the stuff from, points it directly towards the CCD, right? That's the optical design. And to focus it, there is actually another screw here that moves the entire mirror backwards and forwards. Okay, so that entire rig can go left, right, up, down, and it can fully move forward and backwards so that you can go from that to that. So that you form an image right here at this point and not before or after. Right? So the focusing moves the mirror backwards and forwards so that the image forms on the CCD, and the collimator moves left and right so that you're pointing at the CCD. Right? So what's happening here is I failed to collimate because it's pointing off and to the right, right? So it's like literally the mirror is literally tilted. And that's why you're getting this image, right? Okay, but maybe I did it on purpose. No, I didn't. Because it allows us to find out where the center of this image is using something like, here's my Gaussian function. Maybe I added another thing to it. There's an offset. Right? I got more of one side than the other. Oh, that's cool. No one cares, Krismani. Let's do a 2D fit. What? Okay, so we're going to assume that it has some maximum brightness, and it's going to have some line profile in 2 dimensions. And then I'm going to draw contours around it. So I'm going to be able to fit where this guy is in a 2D space. So find my star. That's the goal. I give you 100 by 100, find my star. Bang. Right? Well, come on. No one even thought that was cool. Yeah. What do you mean if there's nothing around it?
Like right now, there's like a whole bunch of other light sources.
Mm-hmm.
Well, you have to mask your image if you want to focus on one star.
Oh, so you're saying like, let's go back to the beginning, right? Here's all these different stars.
Yeah.
You want to do it in here? I mean, it's so remember what dark around means, right? Because there's still stuff in this image, right? It's just not the brightest stuff. So in practice, if you want to grab this guy, yeah, it looks like there's nothing really around it, but there is. Right? There's all this stuff around it. So, you know, in practice, it may grab the wrong one. You can give it multiples and you can have it fit as many as you can find in there, right? This is very flexible code. It's a 2D Gauss fit and say, give me as many Gaussians as you see that are above a certain brightness, right? You can give it a parameter start, right? Say everything needs to be above 0.4 or everything needs to be above 0.1 or something. And then it only fits Gaussians above 0.1. Does that make sense? Okay. And if you really don't want that star, you know, just blot it out. Okay. I think I built something for you for a crosshair. So if you have a different image and you want this one here, you know, you don't know where to find it, don't know how to find this exact point, right? You can like type in an overplot. And so you just like put a different image that has a line in this direction and a line in this direction. And you find the crosshairs of where it is. You just move it around. And so you get the exact location. It's fairly straightforward, but you know, it's something you want to play with so that you have some like familiarity with the Python tool itself. Once the data is down, just consider that it's the data, right? Don't even remember that there's a telescope, except for if you see these types of issues. So as you get really into the nitty gritty, you'll start seeing stars. You're like, ah, shit, it's not really circular. And that's kind of not a problem as long as you can collect all of the light, right? In fact, some people want it a little unfocused, right? Because maybe it's not as saturated. Now, I'm not going to ever recommend this to you, but you'd be like, well, you know, it wasn't a bad night because I just still grabbed the entire Gaussian and I added it all up to find out how much light I got, right? That's a perfectly fine way of doing it. Not one that you would ever publish with, but one that you would be acceptable for this class, right? Okay. So that process of understanding how to go through the data makes sense? Is that something that you didn't know? Did you learn anything right now? No, not really. Okay. That's okay. Let's imagine now what we're going to do with the different images that we have. Okay. So you've gone through the process. You wrote in your notes because you kept really, really good notes. You have these like different files. Okay. And I wrote image MP image and read whatever. Okay. You have multiple images. So you could go through and you could grab all of the different images, right? I promised you something called glob, right? Do you remember that? Here's how to find it. It's so funny, but it works so well. I'll support you. Okay. So, here's how to import it. Import glob. Print named explicitly. So let's say you want all of the files that match this exactly. You say for name in glob, and then it'll point all of them. let's say you want all of the files in a certain directory, you're going to use this asterisk, and that will give you all of the files within that last folder. Versus, let's say you want something that has a number like the word data in it and is a text file, then you would write it like this. Versus if you were like, oh, I want everything with the numbers 0 through 9 in them, then you would write it like this, and that'll just give you all the names. Now you might be thinking to yourself, that's not fucking helpful, Mateo. I don't want to know the names. I want to know the files themselves. That's okay. Because instead of saying image mp read, you can have a vector and you can add to it each one of the files. And they'll be read in as vector 1, vector 2, vector 3, vector 4, vector 5. And then you can go through, and just like we've done before in other classes, you have an array, one array, and one array. You can subtract them, you can add them, you can put them side by side, whatever you want, right? Okay. All right, well, that's all the time that I have for you for lecture. We can take 15 minutes and we can talk about the data processing itself. Tomorrow is an open house, so we can decide if we want to go up tonight alone, you want to go up tomorrow. Don't all talk at once.